and let's say we want to determine limit as x goes to 2 of f of x, and it gives me the graph of f of x right here. Basically, you want to make sure that the left-hand limit equals the right-hand limit. So as I'm getting closer and closer to 2 from the left, I'm getting closer and closer to what value along y? I'm getting closer and closer to 4 along y. So the left-hand limit is 4, and then as I'm getting closer and closer to from the right, I'm getting closer and closer to 4. So the right-hand limit equals the left-hand limit, which means that this limit equals 4. And that's it for that question, but I could ask a follow-up question to this. I could ask you, is f of x, or is f, let's just say f, is f continuous at x equals 2? Now, to investigate this question, you see continuity, you must know the definition of continuity. So the definition of continuity is that the limit as x goes to a of f of x equals f of a. That means that the function is continuous at a. Okay, so this literally means, okay, you could say f is, if this equality is true, you find out this equality is true, then f is continuous at a, where a could be anything. It could be any x value, and in this case we're going to investigate a being 2, because I want to determine if f is continuous at 2. So let's see. So is it true? We just determined limit as x goes to 2, because I'm trying to determine continuity at 2 of f of x. Is it equal, question mark, is it equal to f of 2? Well, let's see. The left-hand side we just determined. We found out that it equals 4. So the left-hand side equals 4, and then f of 2. If I look at f of 2, right, and I go up, I see that the filled-in dot is at 1, and I have that 4 equals 1. Is that true? No. So then this means that f is discontinuous at 2. F is discontinuous at x equals 2. And I could even ask a further follow-up question. I could say, what type of discontinuity is it? And it is a removable continuity. Know that this type is a removable continuity. Removable discontinuity. I apologize if I said continuity. Discontinuity, right? Discontinuity. Okay. And that's just because it's the whole. Okay, if it were something like this, right, if this were f of x and this were here, that'd be a jump discontinuity, and then the infinity continuity, discontinuity, sorry, this is a jump discontinuity here, if f of x is this blue line, and then the infinity discontinuity looks like this. Here you have something like that, where the function isn't even defined, or maybe it is, but it's like one, you have your vertical asymptotes in some regard. That's the infinity discontinuity. This one here, if I had f being this line right here, and f being this original black line, that would be a jump discontinuity, and then the one that we have actually in this original problem is a removable discontinuity.